Thank you very much. This is a real honor and a privilege to be invited here. I met Dr. Zaidi some time back, and he made this place sound really exciting. And so far, you're living up to the promise. So I'm delighted to be here. Listening to the talks this morning was very interesting. Particularly, Johar Saab said he had this wonderful quote from Eleanor Roosevelt that small minds talk about people. मुझे लगता है कि मेरा दिमाग छोटा है. I'm going to talk about people because I'm an anthropologist. So small mind is going to talk about something which I think is actually very, very important here. I also have a background in computing. And when I was sort of hanging out with the IT people, they kept telling me with some contempt, some level of arrogance, that 90% of problems are this LNBK. You all know what that means, right? The loose nut behind the keyboard, right? So it's the person that's the fault. And this is one of the issues that I applaud everything you're doing here, but the thing that keeps running through my mind is a technocentric approach will almost always fail, right? You've got to bring people into this. And I want to illustrate this with two stories, two examples, and then I'm going to talk more practically about what we're trying to do in Aga Khan University, and I think what many universities in Pakistan are now trying to do. I'm going to start way back in sort of after the Civil War. You've also mentioned, I think Professor Hoodboy talked about looking for talent wherever it is. And this is a classic example. George Washington Carver, born into slavery, but revolutionized agriculture in the United States. He looked at the problems of soil degradation and crop failure, and he took a scientific approach to say, what do we do about this? And then he realized crop rotation was great, but people didn't know what to do with the other crops. So an awful lot of what he spent his time doing was not really understanding why soybeans and peanuts were a necessary cycle in the crop rotation. But what could you do with soybeans and what could you do with peanuts? And so he developed what we now take for granted as an extension program, an agricultural extension program, realizing that farmers have to be a part of this, that you can't simply say, okay, cotton, peanuts, soybean, you're done, solved, problem solved. Your soil's going to be good, nitrogen will be bound, everything's good. No, because you've got farmers who don't know what to do with this new crop. So he brought the farmers in. He didn't just say there's a market for peanuts. He created a market for peanuts. He created products that could be made from soy and from peanuts. So he thought not just about the soil science, which was his expertise, but he thought about the entire complex system. Now, George Washington Carver was not doing the molecular analysis that we're talking about today, but it was very much bioengineering. It was looking at the life cycle, looking at the complex interrelationship between the environment and what was going on around it, within it, including the people. And he found solutions. Those solutions caused problems. He then found solutions for the problems he caused. That's a systemic approach. We solve a problem. That cascades into something that we got new problems. It never ends. It is an iterative approach that we must always be thinking about problems and solving the problems that we've caused with our solutions. The second example, the second story I want to give you is much closer to home. When I was a teenager, my mother dragged me out of my comfortable North American existence to live in Pakistan. I lived in Lahore. We started in Lahore American School, and I lived in nice posh areas. And then she said, no, the posh areas aren't good for us. So she moved me into a lower working class area of Lahore, on the outskirts of Lahore, where she could work closely with her informants, with the people she was trying to understand. And I got to see firsthand how important it is to bring together science and sociology. She is a cultural anthropologist, a medical anthropologist, and she was working with the Pakistan Medical Research Center in a very poor area of Pakistan that had been set up for Bihari refugees. And what the medical researchers had found is that Bihari refugees were not getting malaria in the same rates that Desi Punjabis were. And they had all kinds of, this was pre the days when we could actually do the DNA analysis, but they first started with a very medical, clinical approach. What must be different about these Bihari refugees? So they looked at it very clinically. My mother, cultural anthropologist, spent lots and lots of time with the Bihari refugees. In the end, the answer was not a medical, it was not a DNA one, it was a one of poverty. That Bihari refugees were too poor to have knickknacks in their houses, so there was nowhere for the mosquitoes to hide inside the house. And if the mosquitoes are not inside the house, then you get lower malarial infection rates. It was as simple as that. But we only could find that solution with the scientists saying, oh, look, there's a different infection rate. That was important. The science was incredibly important there, but the science didn't answer the question. The science could rule out probabilities, rule out some of the solutions, but they couldn't definitively say what was the cause, what was the solution. So it was bringing them together that made so much of a difference. Now that really informed everything about my training. So as an anthropologist, I went to Northern Punjab and I studied conflict management and I studied resource management. I was interested in how farmers solved problems, how farmers managed conflict. And one of the things that I learned about farmers is they are not the impediment to progress that they are often accused of being. They are that close to failure, complete failure. And if any of us were that close to starvation, you would not be playing games with your future. You would not be taking high-risk strategies. And this is a rain-fed area, Barani area, which, crop failure is never very far away. And so they were very much more mindful than I am, living in my fairly comfortable little bubble in Karachi. I have a long way to go before I'm actually on the street and homeless and starving. They're not a long way away. So we can't compare, we can't say, I'm not criticizing anyone here, but when someone says someone's irrational, particularly when people accuse farmers of being irrational, I say, go be a farmer. Go try being a farmer, because that's a tough job. We're not talking the big agribusiness of the United States, where one company, one big mega company will control a farm the size of Punjab, to be honest. They've got mega farms there. They can afford a little bit of failure. But these are small farmers. They can't afford failure. So it's not about a lack of rationality. It's not about a conservatism that objects to progress. It's about a genuine fear that, what if this fails? So I have seen the extension workers come out peddling these new crops, but they don't really know what the consequence is and they don't know what the market is. So I have seen progressive farmers take on a progressive crop and then there is no market for it. And if I've seen it, every other farmer has seen it. And they're all sort of hunkering back and saying, no, wheat and maize, that'll do me. I'm fine. You keep your other fancy things because I don't know what I'm going to do with it. I have seen total potato crop failure because of disease, because actually it's hard to grow potatoes. True potato seed is hard to find and it's hard to grow in Punjab because it's very hot. Potatoes are very susceptible. So you need quite a lot of support for farmers before they are willing to take those risks. That's where I think this bioengineering comes in. I think if we can produce, not we, you, if the experts here, I'm like Professor Hoodboy. I have no expertise. I can't claim any expertise in bioengineering, but I can tell you that people will take those chances if they have the necessary support. If a place like UIT can spearhead this revolution to try and get this incredible movement happening, then actually the farmers will be on board. We will get the agribusiness moving in the right directions, but there's got to be some level of security. And of course, that's where the state comes in as well. And I think if we look at Holly Sims' analysis of the difference between the two Punjabs between 1947 and the mid-'80s, we see exactly the same trends that Dr. Maroof talked about, that you've got India starting out lower than Pakistan, and by the mid-'80s, actually, that was completely reversed. That isn't a problem of bad farmers. That is a problem of governance. That is a problem of management. That is a problem of the support that farmers didn't have. And I know I sound like an apologist for farmers. That's what happens when you spend 25 years going to the same villages. You start to over-identify, perhaps. In the old days, we would have called it going native, but of course that's fairly offensive in many ways, not just to me, but to everyone around me. So what are the practical solutions? Where at Aga Khan University, we are starting an arts and sciences program. Some people call it liberal arts program. And I was hired to be the dean. And one of my principal missions there is that science is not just a tokenistic contributor to the program. That science is as important to this program as poetry, as music, as creative arts, as anthropology. And now, why is science so important? Why is, earlier we mentioned the importance of mathematics. Why is mathematics foundational? Because it's not simply about the knowledge that is gained. It's about how that knowledge is gained. It's that epistemological process of rigor, of empiricism, of logic, of being systematical, of being methodological, and being able to deal with complex systemic relationships. Because one of the things that I have learned over way too many years studying the same people is that they are complex. And whenever we are talking about people, we are talking about systems that cannot be entirely predicted. They're not mechanical systems. These are organic systems. They are subject to change based on change. So if I introduce a change, such as increasing the number of girls who are educated in the school, I think that's a good thing to do. But I cannot do that naively thinking that will have no negative consequences. That is not entirely a positive. And we've seen that across the board, that when you educate girls, when you educate peasants, lots of good things come out of it, but some problems come out of it. If you have all of your girls now getting wage labor, then who takes care of the household when you still have a social system that says a woman must be in the house looking after the house all the time? Well, what happens is poor women have to do triple duty. They have to work full-time. They have to work full-time in the home, and they get no breaks. So that causes problems. So it isn't simply a case of, we got a problem, let's solve it, boom, we're done. No, we got a problem, we solve it. That guaranteed will cause you more problems. That's a systems way of thinking. So we need that systemic approach. And I think this is one of the things where the bioengineering, and my colleague, Dr. Zara, has given a very good example of that we've got a solution of vaccines, but that solution of vaccines actually needs to be continually tested, refined, and changed. And we need to understand how it's going to roll out in communities where there have been rumors about the dangers of vaccines, which we are seeing not just in Pakistan, but around the world. How do we deal with that problem where we now have diseases like measles, which really were not a problem in the UK, they are now becoming a problem. We've got innumeracy, where you've got, I read this statistic that 1 in 5,000 children who get measles will die. 1 in 100,000 children, this is the bogus report of Wakefield, that he said 1 in 100,000 students who took the MMR vaccine would get autism, which is not lethal. And parents were taking this stupid decision that, oh, I'd rather my child not get autism, but I'll take the 1 in 5,000 risk that they die. And that seems to me a failure in education of science, that we are not teaching our students basic numeracy. We are not teaching our children how to evaluate probabilities in any sensible way. Professor Hoodboy talked about, we're not teaching them to be rational. That's not a Pakistani problem. That's a global problem. We are not teaching our kids to be rational. I was born in Alabama. Alabama has one of the worst scores, only outdone by Mississippi, of education in the United States. Mississippi and Alabama, they're just fighting their way to the bottom. And you see how they vote against their own interests. You see how they make these decisions that are not conducive to their well-being, that are actually damaging and sabotaging to themselves. So we need to bring science into our programs, our liberal arts programs, in a meaningful way. We need the STEM subjects not to be carved out into isolated little programs. We need our STEM subjects to be front and center in our poetry programs, in our history programs, in our political science programs. So this is the practical step that we're doing in the Arts and Sciences program at Aga Khan University, is that first year, all of our students will walk out equally qualified in STEM and humanities, social sciences, and in the arts. Then they get to specialize, and the ideal is that they then are able to look at these complex problems in creative ways and come up with solutions that an engineer all by him or herself would never even think of, because you've got to be able to exist outside the box before you can start breaking that box up to solve those problems. And I think I will just finish with saying that what I'm so heartened by with this symposium is that we are you've already started, but I'm now joining you in this journey of looking at complex problems in a multidisciplinary way. And we're saying that it's not good enough to be an expert in your own field. You've got to work with people who are experts in other fields to try and tackle some of these most pressing problems. And chief among them in my book is climate change, which is never going to be solved with a technocentric approach. That will absolutely require this kind of socio-biotechnical complex strategy. Thank you very much.
Thank you, Dr. Stephen. as you know that we are having live broadcast, so there is a Facebook comment, and looking at your background, I feel that you're a perfect fit to answer that question. So the question is, what are the current trends and developments in the field of bioengineering, and how are they impacting our society? I just brief it up.
Yeah, well, I probably am the wrong person to answer that question, but biomedicine is certainly a booming field in the West. Not necessarily, not the nanobites, not the Star Wars solution where you get little mechanical things that fix you, but exactly what Dr. Zara was talking about, that actually refining the treatment to the genetic profile of the patient. That seems to me an absolutely exploding area. And part of this is, I'm never going to be grateful for COVID, but we have to look at the bright side of these things. One of the things we got out of COVID is the ability to fast track that vaccine development. And that is very much tied to this bioengineering and looking at the DNA. The mRNA vaccines have transformed I think the biomedical field in ways that really 5 years ago we couldn't have imagined.